though it's called data management evolution, we mostly talk about the new trends. Okay, right? Because this is not about the history. You know the history of databases, right? So people start using hierarchical databases. Then, because it's very tight, it's not very flexible. So then they tried out uh, network databases where they start connecting, relating data freely. Uh, Other extreme, but then they found that that is too much of freedom, right? No control at all. So then they settle into relational databases. So it's not as tight, uh, strict as hierarchical, not as loose as network. And here we connect data tables or relations using the relational theory. So there must be, if there's a relationship, there must be foreign key. That foreign key must be connected to the primary key of the related table. And if there's a many-to-many relationship, you need to introduce a connecting table, and so on. Right? So therefore, we have good control. At the same time, we can do whatever we want also. But when we do those things, sometimes it can be little bit tedious, little bit effort is needed. So that is relational databases. And relational databases evolved in 1970s, 80s, and up to 1990s. But in 1990s came object-oriented programming with C++, Java. Okay, post 1990. So then databases start supporting object-oriented concepts. Right? Still, it is a struggle. So we don't have a very good object-oriented databases yet. And that is why we are using object relational databases. Object relational. Bit of object-oriented support and also relational support. Okay. And that is how things evolve. That is how things evolve. Still, we are heavily using relational databases with some features of object-oriented features also supported. And while things were evolving like that, especially around 2000, after 2000, different business organizations, especially something like YouTube, Facebook, start supporting unstructured and semi-structured data, especially semi-structured data. Google search, Google Map, social media, blogging, content management systems. So there was a demand for semi-structured and also for unstructured. For example, Google, YouTube, okay, images, okay, CCTV footages, video calls, audio calls. So support for semi-structured and unstructured. So that is where NoSQL databases came to support semi-structured data and bit of unstructured data. Okay. So that is the big picture. Hierarchical, network, relational, object relational. And from the other side, NoSQL and newer type of databases support which demand support for semi-structured and unstructured data. So we are more interested about support for object-oriented and support for semi-structured and unstructured data. Because this is history now. Hierarchical and network database is just a history. So therefore, we are interested about comparatively understand relational databases, object-oriented, object-relational, and other support for semi-structured and unstructured data. To support semi-structured data, so we have XML, JSON, and some other supporting technologies as well. Right. So that is a big picture. Right. So with that picture, big picture, let's go through the your UCSC note. So at the end of this lesson, you will be able to describe how and why different data management techniques evolved, like to support structured, semi-structured, unstructured. And of course, within that also there are variations. Identify the requirement for object databases. That is obviously because we heavily do object-oriented programming. Explain the key concepts incorporated from OOP. So the concepts that we borrow from object-oriented programming to the databases, because we need to try to support those in database as well, like inheritance, encapsulation. Recognize the importance of NoSQL databases. That is especially because we are now heavily using unstructured and semi-structured data. Describe different data models available in NoSQL. So NoSQL is just a family of technology. So NoSQL support different type, like graph, okay, SQL, sorry, XML, column family databases, key value pairs, and so on. Okay. So we will look at those sub technologies that NoSQL databases support. Analyze the difference between NoSQL and relational databases. Because relational is more for structured, NoSQL is more for semi-structured and sometimes unstructured. Usage patterns and so on. Right. So the subtopics, major concepts of object-oriented XML and NoSQL databases. Then object databases, concepts, okay. Introduction, object identity, literals, encapsulation, operations, persistence, type hierarchies and inheritance, polymorphism and multiple inheritance. Then XML databases, the reason for that, structured, semi-structured versus unstructured data. Okay. Storage of relational databases, semi-structured and directed graph model, and also unstructured data. The XML hierarchy. Okay. What is element? What is attribute? What is document type? What is data-centric versus document-centric versus hybrid data? And then NoSQL database. So origins and what is solution that NoSQL give? We call it impedance mismatch. Right? So data models in NoSQL like aggregate data models, key value model, document data model, column family stores. Okay. And also data models for complex relationships, that is mixing these things like graph. Right? So it's a huge syllabus, okay? Contrast and compare relational database concepts and non-relational databases. Object databases and relational databases, XML and relational databases, NoSQL and relational databases. Data modeling aspects, aggregate versus aggregate ignorant, schemeless versus in NoSQL, and what is meant by materialized view. So that is your syllabus. Okay. Right. So we'll start with object databases. So when we say object databases, you know that it's support for object-oriented programming. So we are not going to look at the relational databases because that is something we have been learning in the other topics, and also you learn it in semester 2 entire semester. Okay. Right. So the object databases, the concept of object databases came because now, especially after 1990s, with C++, Java, later C#, and so on, we now do heavily object-oriented programming. So remember, we have moved from structured programming to object-oriented programming. Okay. So structured programming, we divide or separate data and process. But in object-oriented, we encapsulate data and methods of one entity into one class. Right? Account class, order class, payment class, customer class, and so on. And also in object-oriented, there are concepts like inheritance, polymorphism, obvious encapsulation, data hiding, abstraction, and so on. So object databases are introduced to support some of these features. Still, we don't have a very successful object-oriented database supporting all these features. Actually, it's a sort of a research area, and some small object-oriented database systems are there, and even database systems like Oracle, Microsoft SQL have provided some support for object-oriented concepts, but still no fully fledged object-oriented database. Okay. Right. So the major importance of object database is flexibility to determine the structures and relevant operations of the objects. So structures are something like the data part, operations are the behaviors. Remember, attributes and behaviors, data and methods. In programming side, yes, we have data and methods, right? Instance variable, class variable, instance method, class methods. But database side, traditionally, it's all data, no methods. Okay. But now we try to map methods also. Okay. So remember, it has evolved from network, hierarchical, relational into, now we are seeking support for object-oriented. Okay. With C++, Java. Okay. And object-oriented programming has been a real success. So that is why people accepted object-oriented as alternative for structured, because it's more reusable, maintainable. We can build frameworks using polymorphism. Okay. And if you can develop a good object database, then your programming programs are also object-oriented, database is also object-oriented. So then seamless integration. There's no mismatch. So right, no conflicting situation between your program and database. Now we are in a bit of a conflicting situation. Programs are object-oriented, we think in terms of objects. Database, we think in terms of tables or relations and relationships. Bit of a conflict. Okay. Of course, we do it because we have no other option. But if you can think here also objects, here also objects, it's going to be better, easier. Okay. That is why we are trying to develop object databases, or at least object relational databases. Okay. As a sort of a hybrid approach. Right. So these are some of the object databases. You can see these are not very popular. Right. Some of these databases actually no longer there because those are very high risk areas, research areas. That is why a lot of people, they don't want to spend their time, invest money on object databases because still it is research oriented. Orion system, Gemstone, object server. So those are some object database systems. Okay. Right. So you know that when it comes to object-oriented programming, object-oriented software design, analysis, design, and development, we look at system as set of objects, communicate and collaborate. Right? Communicate and collaborate to achieve common objective or the functionalities. And these related objects, or not related, to represent all the similar objects, same objects, we come up with a class. To represent all the account objects, account class. To represent all the payment objects, payment class. To represent all the order objects, order class. And then that class, we encapsulate both state or attributes and behaviors, operations or methods. So that we say that object or class encapsulates states and behaviors, or attributes and behaviors, or data and methods. And therefore, when we create objects out of class, your object also has states and behaviors. If it is instance variable, Each object has its own value for states. And your behaviors will change those individual states. If it is a class variable, of course, it is a common for the class. And again, your behaviors can access class variables or static variable. And your static methods can also access your class variables, but static methods cannot access your instance variables. Right. So those things you learn in your semester one, right? So I'm not going to teach you those again, because you must now very familiar with those concepts. That is the reason you were in semester one. Understand those things. Right. So then, so when it comes to object-oriented programming, software development, we can identify two types of objects. This may be a little bit new to you. Transient objects, persistent objects. So transient object means, remember when we create a class. So what is the purpose of class? There are two reasons for classes. Can someone tell me what are the two reasons for having class? Anyone? This is something from semester one. What are the two reasons for class to exist? Otherwise, no need of a class. So what are the two usages of class? If you can't answer this question, you have not understood object-oriented, right? Maybe you are doing something else. You think that you know what is object-oriented programming, and you think that you know object-oriented programming, but unfortunately, you have no idea, or you have very rough idea. Anyone? At least you try. What are the two usages of having a class? Say customer class, payment class, order class, account class. Yeah. As a template for common entities. Yes, that is correct answer. That is when you do it. Right. So why do you that is that is what is mean by creating a class. Then what are the usages? දැන් මේ ක්ලාස් එක දිහා බල බල ඉඳලා වැඩක් නැහැ. මේ ක්ලාස් එක දැන් හැදුවට පස්සේ අපිට තියෙන ප්‍රයෝජනේ මොකක්ද කියලා මම අහන්නේ. ඒ හදනවා කියන්නේ මොකක්ද කියන උත්තරය තමයි කිව්වේ. It's a template for those attributes and behaviors or common attributes and behaviors. Now after creating the class, what are the two usages? That is my question. What are the two usages? Think about it. I will give you 1 minute for think, because this is super important for you to think about these things and be very serious, because you are in the final year. Sorry, you are in the level 2. Sorry, you are not in the final year, level 2. That means higher diploma level. Right. So the answer is indirectly correct. Or if you say directly, why do you have a class? One reason is for inheritance. So other classes can inherit your class. If your class is A, one usage is maybe your class B can inherit your class A. Maybe class C can inherit. Maybe if D is a subclass of B, C is also inherit A. So therefore, one reason for having a class is let other classes inherit your attributes and features. So that is usage number one. What is the second usage? Second usage is the main usage actually. So the main usage or main reason why we create a class is second. Still you have not told me. I think I will give you another 1 minute. Yes, correct. So why do we create classes? To create objects. Because when the software is running, right, in the memory, objects are created. So that is the obvious answer. At least I'm happy now at least one of you gave me the answer. So what is mean by running a software? Different objects are created, that object creates another object and call behaviors. Maybe that object create another object, set of objects. So that is how your software is running. So therefore the main purpose of having class is facilitate object creation at runtime. The second reason is support inheritance. And other concepts like polymorphism and so on. Okay, right. So the main reason for having class is create objects. And there are two types of objects. Transient objects and persistence objects. Transient object means you create that object and do something and you forget about it. Right? You forget about it. You don't keep track of the values of that attributes of that object. That is a transient object. But there are some objects we want to keep track of the values. If the value change in your when you run your program, we want to save that value. That is where the database calls are. Okay. So we call them persistent objects. So usually we need database tables or whatever in object oriented, let's call it database object in the database or classes. So we need the database support for persistence objects because transient objects, we don't care about saving values or we don't retrieve values. Those are supporting objects like control classes, objects from control classes, validators, utilities. So it does the work and we don't care about saving the states. Okay, so therefore, when it comes to object database is not more, basically concerned about persistent objects or the persistent classes. So the mapping is between persistent classes and the object, the tables or the classes in your database, not with transient objects. Okay, so therefore, the first thing you must understand is we are not interested in each and every class when it comes to databases, we are interested in persistent objects or the persistent classes. Okay. So in secondary storage, object-oriented databases can store persistent objects and can be retrieved later. Okay. So we are not interested in transient objects. Right. Another concept is object identity. So it's something like primary key in relational databases. So remember, in relational database, every record can be uniquely identified using primary key field. Maybe it's a one single field or set of fields, composite primary key. So you know that is super important. One reason we can use it to uniquely identify a record. The second reason is we use primary key to map it to the foreign key of the other table. Because if it is not unique, that relationship is also going to be ambiguous. Now you must be very serious, right? You are in level 2. So in object databases, rather than primary key, we call it object identity, ID, or object identifier. It's the same concept, but we give different name because now we talk about objects, not records or tuples. And this object ID can be surrogated or system generated. That is preferred, like auto number, or it can be domain value, like NIC or something. But usually, almost all the time, we go for system generated object identifier because then we have better control. Usually, this object identifier is not something end users are interested or it's not usually exposed to end users. Actually, end users are not aware of that. But in our queries, object oriented queries, we will be using these fields, not values, fields to make relationships and so on. So you can see OID might be hidden from external user. So they are not aware, but that concept is internally used by designers, developers when we design and develop systems and of course in the runtime. Okay, so these are some features of object identifiers. It must be immutable. So that means once you set it or once it's generated at object creation and persisted, you don't change it. You can change other attributes. You can change attribute customer's phone number, right? Maybe something else, but not customer ID. Immutable. Okay, because identifies something like your NIC number, you are not going to change time to time, right? It must be immutable. And also, obviously, it must be unique. Unique. Used only once means not used for two different objects, same value. Say one value is used for one object only. Okay. Even when that object is deleted or that record is deleted, usually we don't reuse that. We don't reuse that. We always use machine generated next number. Immutable and unique. Okay. And of course, it is similar to primary key, but here we use different terminology. Right. Next concept is literals. Okay. So literals means something like a field. Okay. Only thing is it's no, literally is not something like a field. Actually, it's something like part of the object. Okay, field is also part of the object, right? Yeah, something like that. But literals, you don't need identifiers, right? You don't need identifiers for literals. Because literals are general values. Okay, right. Your literal can be single valued, or we can call it atomic literal, or your literal can be a structure, set of fields, or your literal can be a collection, like a set, list, map, array, and so on. Bag, dictionary. For example, if your literal is something like uh, your gender, it can be a single value, right? Maybe male, maybe female. But at the same time, it can be a collection. Like you have set of skills, set of contact numbers. So these are very simple concepts, okay? Or it can be a structure. Maybe employees department. Department has multiple fields again. Or maybe your name. It can be first name, last name, middle initials. So then it's a structure. Or casually we call it tuple, but the better word is structure because tuple is something we use in relational database. Sometimes it can be confusing. Single value to atomic literals, structure literals, collection of literals, collection type literals. Collection can be set, list, bag, array, dictionary, and so on. And we will look at the differences between these collections. Of course, you have learned some of these collections in your programming, Java collection framework. Right. So single valued or atomic literal means something like first name, last name, employee ID, date of birth, address. Of course, if you want, you can make address as a structure as well. But if you just take it as single thing, gender, salary. So I hope it's very self-explanatory. Okay. So this is very simple topic, especially the first part. Then you can have struct or structure, or sometimes we call it struct constructor, but it's structure. So it's made up of several components, not atomic or single value, right? Not atomic or single value. For example, employee name can be correct combination of first name, middle name, last name. So then employee name is a structure, not an atomic field. It's a structure field. So in object databases, actually we are not using a specific database technology because these technologies are very immature, right? Keep changing their concepts. Sometimes some databases comes and goes. So therefore, your UCSC not refer to sort of a pseudo uh, object oriented database. Let's assume there's an object oriented database like this. Okay, with these concepts. Therefore, we are not referring to a specific object database, okay, like gemstone or whatever. So struct your structure name, then you can give your fields with data type. Field name colon data type, comma field name colon data type, field name colon data type. Okay. So then you can have collections, or we call it multi-valued. That means it's not one value. Multiple values are possible, like your contact numbers, your skills. Okay. Maybe product has set of items. Order has set of items, odd items. So again, there are variations. Sets, bag, okay, list, array, dictionary. You know that in programming also we have different things, right? For example, Java util package has something called set, something called list, something called map. So here map is represented as dictionary because programming languages like Python, we don't use the word map, rather we use the word map dictionary. So you can think of dictionary as same as map, key value pair. So what are the differences between these collections? Set, you know that when we say set, duplicated values are not allowed. No duplicates allowed. And also unordered. Remember, we discussed sets in semester 1, semester 2 also. Sets order is not important, duplicates not allowed. Okay, order is not important, that means unordered. It doesn't keep things in ordered manner. Even insertion order is not preserved. And duplicates are not allowed. If a duplicate value is added, it will be ignored. Or in some cases, it will give you an error. Back means again unordered, but duplicates are allowed. Duplicates are allowed. So only difference between set and bag is bag allow duplicates. Okay. And of course unordered. You know that when you put something to a bag, it's unordered, right? That is why we use the word bag. Then list is ordered. At least it will keep the order of insertion, or we can sort it. But there's no way you can sort a set or bag. Unless you sort it, list will at least preserve the insertion order. First one, second one, and usually you have index. Then the array. It's again ordered like list, and usually sometimes list may not have the index, or index is not very important, but definitely array has index. Okay. And also arrays are dynamically sized. Now this is contradicting with your Java knowledge. Because remember in Java, array is fixed size. List is variable size. But in this discussion, because most of the time arrays are dynamic in other languages like Python, PHP, JavaScript, arrays are dynamic. So therefore, we go by the majority, let's consider arrays are dynamic size. I know that is contradicting with your Java. Okay. Then dictionary is, just think it as Java map, key value pair. Name, Nimal, say marks is 70. Kamal, marks is 80. It's like array, but array has predefined index 0, 1, 2, 3. Dictionary can have your own index. Maybe January, rainfall. February, say 12.8. Something like that. Okay. Dictionary. So what are the different collections? Set, bag, list, array, and dictionary. Okay. So this is an example of defining a particular type. Type is something like table in relational databases or class in object-oriented concept. Okay. So define type, this is the pseudo sort of a thing. And you must remember this syntax. This is sort of a pseudo syntax. Remember you are in now level 2. You have structured essay paper also. So you need to write. They will give you a small scenario and ask you to write the type definition. Right. Define, it's like a keyword. Define type, your type name. As a convention, they use capital letters, so you also use capital letters in case you get a question. Then you say tuple. Okay. Say this is a department class, so department entity, or in relational databases, terminology department table. D name or any name you can use. String. Okay. So it's a type called department. D name is an atomic attribute, string, department number. Maybe that is the object identity, or maybe just an attribute. Then manager. That is a manager of the department. So it's a tuple. That means again sort of a structure. Okay. With manager of type employee and start date as a date. So basically you are referring to another type called employee. Maybe this is also another type called date. Or if you have built-in data type called type date, that you can use. So when you say tuple, you are referring to another type. Another type. Okay. So then you need to define what is employee separate. Maybe below they have defined, no? Right? So basically you need to define what is employees. And here what is project is. Okay. It's a separate type. Right. So then locations, that is maybe this department exists in multiple locations. So they have taken it as set of strings. Maybe Kandy, Colombo, Anuradhapura. So they have taken it set. Maybe they are not interested in order. And of course, duplicates are not allowed, right? You can't say that that department exists in twice Colombo. So therefore, likewise, you need to use your common sense and pick the best one. Employees, again, they have considered it as a set of employee. Again, order is not important. Duplicates are not there, right? Obviously, you can't have duplicates. In projects also, they have taken it as sets. Of course, project you need to define separately. That is a project handled by this department, maybe project handled by this department. Okay. So this is how you define a type. It's a tuple, but your manage is also tuple because it has two fields. These are collections. These are atomic values. Atomic values, another tuple, different collections. In this case, all are sets. Okay. So make sure you do these activities, okay? After spend a little bit more time, understand. So then only you can do the activities, like straight away you will not be able to do it. So the next concept is, of course, there's another object-oriented concept called encapsulation. So therefore, when we work with object-oriented databases, we try to support that as well. Actually, I use the word try to because these databases are still evolving. Okay, that is why we are using sort of a pseudo coding. So therefore, in databases also, we try to support as much as possible the concept of encapsulation. So remember, encapsulation means we bind data and methods to one entity called class. Your class has not only data, behaviors or methods. So we encapsulate it into a class. So in your database also, if you go for the concept called class, so then maybe not only data, maybe we can provide a bit of support for behaviors. Usually we support behaviors in the business logic layer or the program layer, but there can be some methods at database layer as well. Okay. So then data and operations both encapsulated into your class in the database, not the class in, of course, class in your program already having those things. Okay. So that is another concept that we try to support as much as possible in object databases. Okay. And also remember, there's a strong form of encapsulation. Sometimes we can take it as a different concepts as well. Data hiding. So that is again something you learn in semester one programming. So data hiding means we make our data private so that other classes or other objects cannot directly access your data. And if they want to access data, they need to call the behaviors. Right? You hide your data and let other objects access it through behaviors. Now, this is something we can do in database. Now, remember the database is all about let others access data. Now, this is a little bit counterintuitive. Right? So, database is all about facilitate other tables to access your table or do joins and so on. But here we say other, that means your class is not supposed to expose your data. That is what data hiding. So other classes supposed to access your behaviors. Now, if we can support, provide some behaviors in our database, so then let other object call your behaviors and those behaviors access the data. That means in the database also now we have a bit of behaviors because we want to hide some data. Okay, hide some data. Okay. So you can see sometimes we need to think in completely different way because sometimes otherwise if you just think like relational way, you can't do data hiding. Okay, you can't do data hiding because relational database is all about exposing your data to the other tables through foreign keys. So that, and sometimes we can hide some data, expose some other data because you can have public fields as well, right? Maybe hidden data you only access through behaviors in the tables or classes. Exposed data, maybe you can directly access. Okay. Visible attributes, hidden attributes. Visible attributes can be seen and directly accessed by the database users, or basically when I say database, when we say database users, basically other classes. Hidden attributes completely encapsulated and make it private. And access only through predefined operations. So these are the operations in the class, database class, right? Not the program class. Right. So I already used the word class. So therefore now what we are going to do, let's have the concept called class in our database also, in our object-oriented database. So that means it has both attributes and behaviors, data and operations. And some data, that is hidden data, can be accessed only through the operations. If other class or other object need to access it. Okay. So additionally, your class can have object constructors and destructors. Remember, constructor is called when at object creation time. Destructor is called at object destroying time. We no longer need that object. And if you have made our data, some of the data or all the data or some of the data private, then of course you need to provide object modifiers. So these are something like the setters in normal programs. So that you call the object modifier, the other objects call the object modifier, and through the object modifier, some private data can be accessed. Hidden fields, hidden data hiding. And you can provide some other operations to retrieve information now. So it's something like the getters. So that is when you have well encapsulated class. Some attributes you have exposed directly for the other object to access, but some other attributes like private attributes, you must use object modifiers to change values and some retrieval methods to retrieve the value because those are private, made hidden. Now earlier we look at now we'll be very serious, okay? Earlier we look at structure. Example for type. So here you don't have any behaviors, right? Define type department, tuple, then department name, department number, then manage is another tuple, location is set of strings, employee is set of employees, project is set of project. Of course, employee and project types you need to define separate. Now here you don't have any behaviors. So if they ask you to write a type, write a type. Okay. So then no behaviors, no private things. But if they ask you to create a class, okay. So this is an example of a class. Define class. Because if you are not very serious, sometimes you don't see the difference. Now this is define class department. And class have type and operations. Type and operations. Now this is your type is a tuple because it has multiple fields. Department name is atomic field. Department number is atomic field. Manager is another tuple where manager and start date. Then sometimes you might be wonder why do we need manager and start date? Actually, ideally this should have been collection as well. Maybe this is the current manager. Current manager. Okay. Because his manager can change. Or department can have different managers at different times. So that is why they have maybe they are only interested about the current manager. Then manager is also a tuple or type, and this is the start date. What is the starting date of that manager? Who at which date this manager was appointed? Current manager is appointed. If a new manager comes, there will be another employee here and due date. So up to this point is your stop type. I type. Then you are in the class. Now this is the type that we look at earlier. And then you have the operations inside your class. So your operations, so this is the end of the department. This is something like sudo. Okay. So then you might be wondering how comes this number of employees a operation? Okay. So number of employees is a field, right? Now value. And it has a data type also. So this is how you write it. So basically number of employees means we need to calculate this. Okay. How many employees are there? Or it can be a getter. Get number of employees or set number of employees. So it's operation. You just specify the field, but reality, you access it through maybe a getter method, setter method, and so on. Then create department. Obviously, you can see that it looks like a method, right? Create department. It's a with operation. Delete department and return boolean. So, okay. Assign employee. That looks pretty much like an operation. So you need employee as a parameter. That employee is assigned to department. That employee is assigned to department means what? That employee object is added to this employee's collection set. So when you call this assign employee with the employee object, basically you add that object to this set, employee set. Then remove employee will remove that employee from this set. Okay. Now, ideally, you must have another set of methods to set the project. Okay. Here set means the set, right? Set collect data structure. So just like maybe assign employee, maybe you need another set of methods to manipulate projects. Of course, those things are not here because it's just a part of the type class definition. Okay. So be very serious because in the exams they may ask you to write a tuple or type, or maybe they ask you to create a class. So then class can have tuple plus operations. Okay. And so this is another example called class called student. So then you need to have a type. And this is the end of the type, then set of operations. And then end of the class. First name string, last name string, NIC string, birth date, address string, gender char, and department. Department is another type or maybe another class. We don't know. maybe a class, maybe a type. And then the operations. Age means basically get age, set age. Right? Create student, like a constructor for this class. Destroy student, something like a destructor. Or maybe some other operations. So it will take a bit of time for you to understand this, okay? And also, since we don't have much of a good object databases yet, uh, we can't do this as a practical session as well, of course. If it is a practical session, you may get it a little bit better. But they have not, UCSC also, even they haven't recommended a particular object database as well. Because different object databases, the syntax and everything is different, okay? So therefore, I just concentrate on the theory. Right, so make sure you do these activities, right? Right, so we all discussed about the difference between transient object and persistent object, right? Persistent objects are the one that we want to save the states. Transient objects, usually at database side, we are not interested about transient objects. Only in the program level, business logic and UI and blah, 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 the transient objects are there, okay? Right. Now remember, if it is a persistent object, we want to persist that object. Save. Maybe insert and save, update and save, or maybe delete. Okay. And also we need to retrieve data from that object. That means from the object database, corresponding object. So how do you access that? And also remember, one object can be related to another object. Maybe department manager is an employee object. So department has a connection with another object, a manage object. Maybe set of project objects. There are connections, relationships. So first of all, how do we name these objects or classes? And how can we access those objects? For example, how to access a department object. From the department object, can I access its manage object? From the department object, can I access its project objects? So that is what these naming mechanisms and reachability mechanisms are talking about. Okay. Remember, in programming, we use the dot notation, right? Say account A1 equal new account. Then we can say A1 dot deposit 1,000. So dot notation is used. Then A1 dot do something. Then in that method, there can be some other objects created. That is how the object-oriented software is running, right? Right. So we don't go into that levels in object databases because object database is not to run business logic. Right. How do you name an object, not a class object? Okay. One way is we can assign a name to an object just like in programming. Account A1 equal new account. Other thing is you can access object when you create object and give it a name. If it is related with another object, so that object also you can access now. Like when you have a department object, and now you have access to its manage object as well. Maybe you have access to set of project objects related to that department. Okay, that is called reachability. Can I reach a Y object from X object, or set of Z object from Y object? Okay. So therefore, yes, sometimes we access object directly by its object instance and giving it a name, but most of the time, majority of objects are accessed indirectly through that one object. Maybe one or few objects we access through names. We create the objects. But most of the objects are accessed through those objects. Maybe few X, Y, Z object, but so many other objects we reach through this. So once you access a particular department of employee object, now we have access to its manage object, right? Maybe from if it is a department project objects, right? So that is not by name from this object. Okay? So we can reach out other objects from one object. We can directly reach an object by name, but from that object, maybe we can access some hundreds of other objects. Maybe from here we refer to this object, from here we refer to this object, and so on. There can be object network, object graph. So the reachability mechanism works by making an object reachable from some other persistent object. So one no set of objects are accessible through another object, another persistent object. An object B is said to be reachable from an object A if a sequence of references in the database lead to the object A to object B. That is exactly what I explained, right? From your department object, you have access to manage object and also set of project objects and so on. Or maybe set of employee objects if you have collection of employees in your department class. It depends on the way you define your class. Okay. You can see when you have access to the department object, from that object you have access to maybe set of employees. Set of employees belonging to that department. That is reachable. That is reachable. Now you have not only access to a department object, set of employee objects, maybe set of project objects as well. From department object, now you have reached to a set of employee objects, set of project objects, and so on. And of course, there are some methods to add another object to your employees. Maybe remove a particular object from your employee object collection. So now you manipulate objects also through your operations. Not every operation manipulate your objects, but some operations may be manipulating your reachable objects in your sets, collections, or tuples like this. So set, list, and blah 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 collections. Tuple means single object, but it's also object, not a collection of object. Okay. Is it clear? And remember, in relational databases, of course, if it is in a table, it's persistent. But in object-oriented databases, we may define some classes which are not persistent. But most of the time, 90% of the time, your classes are persistent. But there can be some classes, in rare cases, it is maybe to reach other classes and so on. Maybe those classes are persistent, but maybe your original class is not persistent, it's transient. Okay. Right. So remember, in object-oriented programming, we have concept called inheritance. One class can inherit from another class if it is single inheritance, or if it is multiple inheritance, we support one class can even inherit from multiple classes. This is single inheritance example. Okay. So remember, subclass inherit both non-private attributes and non-private behaviors. So the result of inheritance is type hierarchy or class hierarchy. Okay. So you are familiar with this terminology, right? Subtype, supertype. So when there's inheritance like this, B is a subtype of A. A is a supertype of B. Then when we create classes, object databases, if we can provide those features, saying that my B class is extended from A class, so then we can use reusability at object class level as well in database. Okay. Something like this. Student is a person. Then we can say student extend from person. Employee is also made person. So then maybe some basic attributes like NIC, name, address, date of birth can be inherited. Just the additional things like NIC, salary can be added here because other things are inherited, both attributes and behaviors. Okay. So this is in your pseudocode database or database language. This is the convention we use. So in the exam papers also, question may refer to this standard, or if you are supposed to write an answer, use this pseudo keywords. Employee, subtype of person. Okay. So therefore, all the non-private attributes and behaviors are now available to employee. And these are the additional attribute, employee ID, because employee ID is not part of the person. Salary, hire date. Here no behaviors, only the attributes added. So student subtype of person. Then registration number, index number, GPA are that additional attributes for student. Other than attributes inherited from person. So likewise, we can create hierarchy of types. Variable partition class can types. By class cannot behaviors and getters, setters, and constructors, destructors, and so. Otherwise, we can say type. So these are some examples of type hierarchies. So type hierarchies results in inheritance. Geometric object is a class, those are the attributes. Okay. Sorry, not a class, type. No behaviors. Then it says circle object subtype of geometric object. So therefore, my circle object has all these attributes inherited. Then additionally, they have introduced another attribute called radius. So that means my circle object has name, color, area, calc area. That calc area means definitely this is not a type. This is a class because calc area means it's a calculation behavior operation. So my circle object has name attribute, color attribute, area attribute, another attribute called radius, and possibly calc area behavior. And rectangle object is also subtype of geometric object. So therefore it also has name, color, area, width and height. Here radius, here width and height. So that width and height can be used to create the area. Here radius can be used to create the area. That is why you have calc area behavior. That is inherited to both circle and rectangle object. But if you are familiar with object oriented, now you know that definitely you need to override calc area because here it's 5r square. Here it is width into height. But you must define it so that you can use polymorphism then. Then semester 1 වල හරියට object oriented concept ඉගෙන ගන්න හරි lazy. බොරු කරා නම් then on the chart. So you are supposed to override calc area method using radius here and using width and height here. Okay. But it's very important that you define the methods in the supertype so that I can send my circle object, rectangle object for calc area behavior defined somewhere else. Because we have your overwritten version will be called polymorphically. That is how you create frameworks. Okay. So this is how it looks. Geometric object class and circle object and rectangle object subclasses with its own attribute, and they have even added another method, behavior, get radius. Here width and height, two more attributes, and two more methods, getters, get width, get height. Of course, here it is not mentioned. Definitive rectangle object must override the calc area. Circle object must override the calc area, because here your calculation of area involves this radius. Here calculation of area involves width and height. Here actually calc area is abstract method, because at this level you can't define how to calculate area, because it's general or the abstract concept, geometric object. දැන් මම කියන්නේ කොච්චර තේරෙනවද කියලා මම දන්නේ නැහැ. semester 2 1 හරියට වැඩේ කරා නම් semester 1 එකේ අපේ classes වල හිටියේ නැති ඉන්නවා නම් හිටියේ නැති අය ඉන්නවා නම් හරි. ඔයාලට ඒ ගැන තව පොඩ්ඩක් දැනගන්න ඕන නම් so go to our YouTube channel. YouTube channel එක කියන්නේ ඒක තමයි ඔයගොල්ලන්ගේ recordings එක දාන්නේ හරි. ඒකේ මම public දාලා ඇති 3ක් හරි. Introduction to object orientation, that is part 1, part 2 inheritance, part 3 polymorphism. Polymorphism එක මම අද අප්ලෝඩ් කරේ can semester 1 student ලගේ object oriented programming වල මේ වතුන මම ඔය තුන public දැම්මේ මොකද ඔයගලන්ට semester 2 3 වල සමහරවිට ඔයගොල්ලෝ 1 හිටපු නැති අය ඉන්නවා. You can refer to those. Okay, you can refer to those. That means if you have forgotten the object oriented concepts, right? So you can't forget object oriented concepts and learn about object oriented databases. Right. Right. So remember that inheritance can be done in single inheritance and also multiple inheritance. So languages like Java, Python, PHP, so only support single inheritance. So multiple inheritance was supported by C++, but pretty soon software developers identify that multiple inheritance is not a good thing to do. That is why all the other programming languages, new languages only support single inheritance. Because if you allow multiple inheritance in programming level or database level, you get into an undesirable feature called deadly diamond death. Because someone might use inheritance like this. A, B, C, D. So then you don't know if A has a particular feature called X, you don't know whether you got it from this side or that side. Right? And also, if X is overridden, say there's X method here, abstract method, say it is overridden here. Now, when you don't know, not very sure whether you inherit from here that way or that way, then you don't know whether should you use the override version or original version. If inheritance is through this, you must use original version. If the inheritance is through this, you must use the override version. But now there's a confusion whether you think like this or that. So that is why multiple inheritance is a bad idea. Rather use interfaces so that a class can implement any number of interfaces, right? So if multiple inheritance is allowed, we ended up in something like this type lattice, diamond-like lattices, which can lead to ambiguities. That is why almost all the modern programming languages do not support multiple inheritance, and of course in object databases also it's a bad idea to support multiple inheritance. Of course, when the program doesn't support, you don't need to support, right? So this is the result of multiple inheritance type lattice. Okay. So you don't know whether a particular feature inherited from this part, that part, or the other part. That's ambiguity. Right. So the resulting ambiguity, if you allow multiple inheritance, which initially create a type lattice, and then confusion of which path you inherit that. This is an example. For example, both manager and engineer may have a function called salary. Like you can see, manager and engineer. Then you don't know which function to use if it is your engineering manager. Is it engineer's function or manager's function? Ambiguity. If manager and engineer supertypes have different implementation for salary function, and ambiguity exists as to which of the two is inherited by the subtype engineering manager. කොයි එකනවත් දැන් අපි ඉන්නේ ජුලාපි. Actually, there are solutions to this problem, but those solutions are going to make your coding a little bit overcomplicated. So, simpler approach is do not support multiple inheritance and rather let them, if they really want to play multiple roles, let them implement any number of interfaces. Okay. These are some other simple solutions if you still want to support multiple inheritance. So the simple solution is do not support multiple inheritance. Rather provide the concept called interfaces. But if you really want to support multiple inheritance and still you want to resolve the ambiguity, so these are the three possible solutions. Check for ambiguity during the creation of subtype and let users or developers to specify the function which should be inherited. So that means when you have this kind of a situation where both has the same function, you are now inherited from both A and B. Now here you need a way to specify whether this class must inherit X, the method say who in X class or Y class. Because otherwise at runtime, how can your computer determine that? That is one solution. Okay. Specify the function which should be inherited, whether it's function X from here or function X from here. Or use system defaults. Maybe when you create like that, one of the class is considered the default supertype, unless you specify. That is also solution. The third solution is check for name ambiguity and deny multiple inheritance. Okay. If that kind of a same method is there, otherwise you allow multiple inheritance. But the moment get into that ambiguity, you don't allow that to happen. You allow multiple inheritance, but you don't allow, for example, two methods with same name exist here. You can have that method in the supertype, but not in these two subtypes. Especially don't allow to override or have two methods of same method implemented by both X, Y. Then we don't know whether it's we inherit this method from X or Y. So another concept is selective inheritance. So remember in programming like Java, whether you like it or not, when we say A extend from B, you get all the features from B, and B extend from C, all the features from C, B into A. Selective inheritance means in your subtype, the moment you say A extend from B, then A must be able to say, I don't want to inherit these things. Of course, B can say what not to inherit by making it private. But now A also must be able to say, I don't want to inherit certain things from B. That is where you can have the except clause. Except clause. Okay. Right. So then the polymorphism. Of course, polymorphism in serious level is object take multiple form, but this is not serious polymorphism they talk about. This is basically operator overloading. Okay, operator overloading. Same operator can be used for multiple meanings. Or else you can go for, when we say operator overloading, actually you're not refer to method overloading. Okay, method overloading. Method overloading is not a serious polymorphism. Okay, but this is just a simple, basic concept of polymorphism. This is not actually object level of polymorphism. You know that you can have different methods with same name, right? But different number of data type of parameters. So then, for example, if you send only one parameter, this will be called. Two parameters, two float values, this will be called. So that is also sort of a polymorphism. So it will, you can call the correct overloaded function with matching with your number of parameters and data types. Okay. You can see calc area method is overridden. So depending on your object or parameters, the correct version will be called. I don't know, this note is talking too much about polymorphism. Okay. Maybe because maybe they think that now you are a little bit matured. Now, not everyone in the semester one is in semester three. So therefore, you guys are now a little bit matured, or good enough to understand polymorphism in a little bit more serious manner. Right. So basically, program level, object level polymorphism is dynamic or late binding. At the running time only, your actual object is determined. So therefore, maybe you are expecting an animal, but maybe you are getting a dog. So that is fine because dog is animal. That is called late binding. Check the object type during the program execution only, not compile level. Okay. Right. So now we are done with object databases. Object databases. Right. Now we move on to our second type of databases, XML databases. We are done with object oriented. Right. So remember the reason for object databases is to support object oriented concepts. But for the reason for XML database is slightly different. So the reason for XML database is to support semi-structured data and bit of unstructured data. Okay. And the next one is NoSQL databases. That is also again semi-structured and unstructured data. Okay. So therefore, our focus is a little bit now different. And you know what is XML is, okay? Remember in semester 2, before doing HTML, I did your small session on XML. XML is a meta markup language. So you can refer to that note. XML is not a markup language. It's a language about language. It's a language that define some framework or rules to define your own markup language. So therefore, XML doesn't have any tags. XML define what are the possible contents, right? Elements, attributes, and entities. Then it defines the concept of namespace so that there won't be any conflict between different markup languages using the same tag name. And also the concept called validity and well-formedness. Well-formedness rules, every tag must have closing tag. There can be only single root tag. Okay. Tags must be properly nested. well-formed rules. We did all those things at semester 2. And if you want to validate whether a particular XML document is according to the expected structure, you can use DTDs or the XSDs, XML schema, to define the structure. So then even a tool can validate whether the document comply with the expected DTD or the XSD. So XML define those three. XML define what are the possible things. Of course, the possible things are tags or elements, attributes and entities. Entities are like ampersand and BSP. In the concept called namespace, so that we can use the same entity or tag names different people and even in the same XML document. And the concept of well-formedness rules and validity mechanism, DTD or the XSD. Okay, so if you are not very familiar with XML, the best place is go to W3 schools. There's no other better place. Okay, W3 schools. Go to XML tutorials. It's XML. XML, learn XML. So there you will learn about XML. Okay. Namespaces, validity rules, well-formedness, and so on. Okay. Sorry. Right. So let's move on to XML databases, right? Our task is not learning XML. Our task is, because you learn XML in semester 2 before learning HTML. So remember, XML has tags or elements. Element represent a concept. Remember, XML is meta markup language. You can create your own XML language, XML based language. For example, this is an XML document I just created right now. Okay, let's say I have something called course. A course has a name, say BIT, name, maybe course fee, say 120,000 fee, maybe then same as subjects, maybe same one, then subject 1, subject 2, subject 3, subject 2, then same 2. So likewise, I can define an XML document. So if someone else can define something else for a maybe hotel restaurant menu, maybe customer order, right? And so on. But we need to make sure that we use only these concepts called tags or entities. Additional things you can provide using properties like attributes, like, okay, say course type is external, type is attribute there. And make sure you write to XML using well-formedness rules. There can be only one root tag. Every tag must have closing tag. Tags must be properly nested. Okay. And there's an alternative for XML also now that is called JSON. So JSON is a little bit more flexible and lightweight because in XML we have a lot of tags. Right? And not only one tag, you have two tags, starting tag, ending tag. So therefore, XML can be a little bit bulky. That is the little bit disadvantage when it comes to saving, because you need to save the tags also. And also transmission, data transmission, XML document will take more bandwidth. So as a solution, we have another alternative for XML called JSON. Okay. Because JSON is a little bit more compact, but not as descriptive as XML. So there are process and cons. Okay. But just remember, JSON is alternative. In NoSQL databases, we heavily use JSON rather than XML. But in XML databases, we use XML. So there is another difference between XML database and NoSQL database. NoSQL databases prefer JSON over XML. Okay. And JSON is little bit more flexible than XML because XML is little bit restrictive or controlling the structure. JSON give you a little bit more freedom. Okay. So XML documents are called self-describing document because you have the tags. Of course, if you use your tag names, attribute names meaningfully, it's a little bit of self-describing document supported by DTDs and so on. Remember, HTML is also XML-based language, not 100% XML-based. Of course, if there's a strict form of HTML called XHTML, which comply with XML rules. But the normal HTML we use is not strictly following XML rules. But the idea is basically borrowed from XML. Okay, so therefore you can think that loosely HTML is XML-based language, markup language. But HTML is display-oriented thing. But XML can be used not only for display-oriented things, data transmissions, data storage, and content-oriented things as well. Okay. So you must have a very good understanding about what is XML, what is HTML, what are the differences, what are the similarities. Until you get that, you must do your studies. You must ask questions. You can ask questions from me at any time, WhatsApp, or ask from ChatGPT, read some tutorials. Okay. Because you can't understand XML databases without first understanding what is XML. Okay. Fine. So this is a relational database table. Okay. Relational database table. So you know that relational database tables have very strict schema. So we define what are the fields, what are the data types, what is primary key, what is foreign key. Okay, very strict. And even we define the data type. So then if it is number, you can't have characters. If it is integers, you can't have decimals, and so on. It's very tightly controlled thing. But those are structured data. But when you need some semi-structured data, we need bit of flexibility about structure, about the data types. So that is where XML is better option than going for a relational table. Or in other words, XML database is a better option. Right. Data may have certain structure. However, not all the data has the same structure. Semi-structure. Right. No predefined schema. Relational databases are for predefined schema data. So the semi-structured data can end up like a tree type structure if it has little bit stronger structure, but if it is even looser, or the structure is even more loose structure, then you will end up in a graph data structure. Usually XML is tree data structure, not a graph data structure. So that is why I told you XML is not for very loose, unstructured data, semi-structured data. Some structure is there, at the same time you need bit of flexibility. So that is where XML fit. But when you lose more and more your structured nature, then maybe JSON is better. Right. Actually, this is not a directed graph. This is actually a hierarchical thing. Okay, I think maybe this is a spelling mistake or very loosely mentioned. You can see this is not a graph. graph means you can connect to again like this. So in data structures and algorithm, we have already discussed about binary trees, okay? Binary trees. So our next topic is graphs, because we need to finish a little bit of trees as well. But graph means these things are connected like this. Right? So therefore, XML is not really a graph, rather a tree. Okay, tree. I don't know why they always call it graph, but actually they're referring to a tree here. Okay. So remember this terminology we all discussed, right? Internal nodes, leaf nodes. Internal node means it has children. Leaf node means no children. Okay. Right. When it comes to HTML, which is content oriented, you know that HTML can have text, even images, video can be embedded. So therefore, HTML is supporting, of course, while providing a bit of a structure, it facilitates unstructured data to be included. Right? It provides a bit of structure. At the same time, it facilitates unstructured data into your page. Okay. That is very important to understand. Right. So this is a sample HTML. Right. You know what is HTML. Okay. So provide bit of structure like HTML tag, head tag, body tag, H1 tag, table tag. At the same time, within your paragraph, H1s, images, unstructured things can be included. Okay. So therefore, HTML is little bit more unstructured than the original XML. Okay. That is why even when writing HTML, we don't strictly follow XML rules. And your browser is also not expecting strictly following HTML rules. But if you want to strictly follow HTML rules, that is called XHTML. Okay, so if you go to the W3 schools, tutorials, and go to HTML, they will mention about HTML and XHTML. Where is that? You can see HTML versus XHTML. XHTML is a stricter. It's more strict, more XML based version of HTML. Okay. So XML is markup language where all documents must be marked up correctly or well formed according to the XML rules. Okay. Elements must be properly nested. Right. All the elements must have closing tags. Okay. The background එක තියෙන්න ඕන. හරි ඒවා දන්නවා විදිහට දැන් මේ කරන්නේ. Right. As I told you, XML, you can create your own XML. Actually, what you do is you create XML-based language and create a document. Anyone can create XML-based language. HTML is also sort of XML-based language, of course, XHTML. So when I just create something like, say, menu, now I'm creating XML-based language and creating a document from that. Okay, say item, name, say fruit salad, name, maybe price, 250. So So on the fly, I am creating a Excel. I am not creating an XML document. I am creating an XML based document. Okay, XML based. Actually, I am creating XML based markup language, and using that markup language that I just created, I create a document. That is exact wording. If you want to explain it in a very formal manner. So what I did, I created XML based language, and using that markup language, my own markup language, I create XML based document. Actually, document based on my XML based language. Okay. Anyone can do it. Anyone can do it at any time. Okay. So therefore, I told you that XML is gives you a hierarchical thing because XML has well-formed rules. Every tag must have a closing tag. Tags must be properly nested. Especially those that rules saying tag must be properly nested. Preserve that it is a hierarchy, not a graph. Like for example, uh, you start. If I take HTML as example, HTML, HTML. So then head, then body, close the body. So HTML, head, body, then title, meta, then any number of headings, maybe paragraph, table. If it is table, then TR, set of TDs, another TR. So it is sort of hierarchical. Okay. So therefore, though it's not very unstructured. Okay. Something like this. Something like this. Okay. So again, you can have simple element. Simple element means something like this. So inside the element, you just have a text. This is a complex element. That means inside the employee element tag, you have sub element. So therefore, employee tag element is a complex element, whereas name element is a simple element. Okay, simple element. So remember, these elements can have a meaning or semantic, and there can maybe we need to have a proper structure. Inside the employee element, you can have NIC and so on. So that is called old approach is DTD that define your structure. New approach is XSD or schema, XML schema. So your XML schema or DTD can define what is your expected structure. And even software can validate a particular XML document against the DTD or the schema. Okay. So if you are interested in schema and DTD, again go to the tutorials. So there will be something called XSD or schema. Or you just do Google search. W3 schools scheme for XSD. Okay. So that is how you define your structure. Okay. So another alternative is DTD, old approach. Okay. So therefore, XML is pretty structured. Okay. But not as structured as relational databases. At the same time, you have the flexibility. Okay. Right. So I already explained what is simple element. Simple element is something like name. Complex element means inside that you again you have elements. Okay. Schema document. Right. So when it comes to XML documents, that means you create a document from your XML schema, your XML structure. You define your tags and you decide under that tag there should be another tag and so on. So that is called schema or D. Okay. Expected structure. So then you can create your documents. So we can classify XML documents into three: data-centric XML documents, document-centric XML documents, and hybrid. Hybrid means mixture of those. Okay, mixture of those. Right, data-centric. So data-centric means you have predefined schema. So that is, though now data-centric documents are more structured, relatively structured than document-oriented. Okay. Hybrid means some parts are structured, some other parts are less structured. You have mixture of both. Okay. So data-centric documents are more structured. There are situations you need to send bit of structured data in XML. So tags are organized in a highly structured manner, and the order and positioning of tags matters. හරියටම ස්ට්‍රක්චර් එකක් තියෙනවා. ඒකේ පොසිෂන් එක පාව වැදගත්. ඉස්සෙල්ලා ඉන්න නේම් එක, ඊට පස්සේ නම්බර් එක. ඔය දෙක මාරු වෙන්න බෑ. ඉස්සර වෙන්න බෑ නම්බර් එකට. So then it is a data centric XML document, more structured version of XML. Okay. Usually for this kind of data-centric XML documents, we are really interested about defining the XML schema or DTD. And we can even validate again that and see whether this XML document is valid. Okay. Other than it is being well formed. But when it comes to document-centric XML documents, we need to give that document a little bit more flexibility. Maybe not very strict schema. Okay. So large amount of text, news items, and blah, blah, blah. For that kind of a thing, we must be a little bit more flexible. So there are few or no structured data elements for these documents. So usage rules for tags are very loosely defined. So usage rules for tags are loosely defined. So that is why we are not much interested about XSDs or DTDs, because those are strict. If you try to validate using those, then you lose your flexibility. So something like HTML pages are pretty much document-oriented XML. That is why even HTML itself is not 100% XML base unless you use XHTML, because the contents are not very structured, right? Very structured in a web page. Hybrid means some contents are fairly structured, some other parts are not very structured, mixture of things are there. Okay. Right. So that is XML based databases. Actually, what we learn is mostly not databases, XML. So that means XML based database means what? When we say save data, you save XML documents. XML documents. Okay. Maybe XML documents for student details, XML documents for payments, XML documents for order, and so on. So those databases save your data as XML documents. Some data can be fairly structured, then it's a data oriented, or fairly unstructured. Document oriented XMLs are saved. Okay. Right. So the third type of database is what we discuss is NoSQL database. NoSQL databases. NoSQL databases internally mostly use JSON or any other. Sometimes we can decide whether to use JSON, XML, or even something else. Okay. So the NoSQL database is to support, say, again, semi-structured and unstructured data. But NoSQL databases are more flexible than XML-based databases, especially when data is getting less and less structured. Okay. So relational databases, the main issue is relational databases expect or demand highly structured data. But most of the data that we use, unless it is related to order processing, inventory management, right? Those are not very structured. Those are structured, yes. But if you take something like social media, blogging, news sites, those are not very structured. So for there, we need more flexible, semi-structured and unstructured support. That is where NoSQL databases are. Okay. So that mismatch is called impedance mismatch. Okay. So database, I mean the relational databases. Relational databases expect structured data, but our data is not that structured. So that impedance mismatch is less when it comes to XML, even less when it comes to NoSQL. Okay. So the word we use is what? Impedance mismatch. The term used to refer to the dissimilarity between the relational database model and the programming languages or the data structures in memory. So the data that we use in memory may be very unstructured. It depends on your application. But relational databases always demand structured data. So therefore, when our data is not structured or less and less structured, relational databases are not going to work. Either XML based or NoSQL. When your data is getting less and less structured, even XML base is also not good enough. NoSQL is better. Okay. So let's keep explaining about the impedance mismatch. Okay. Right. So when it comes to NoSQL databases, it try to address this issue of supporting semi-structured and unstructured data. At the same time, it's address some more concerns as well. So these are called unstructured, semi-structured data. These semi-structured data, especially semi-structured and unstructured data, sometimes we call them big data. So the reason is these data comes in big volumes. So therefore, another very important feature is performance, scalability. That means sometimes millions of users use it, like Facebook, YouTube. So when it comes to NoSQL databases, they try to address all those issues, not only supporting less and less structured data, but to support scalability, reliability, and so on as well. And also the usage patterns of these type of data. Okay. Scalability, availability, not just unstructured nature or the same less structured nature. So these are all usually we need to work with large volumes and large number of users accessing. That is one reason when we say NoSQL databases, mostly those databases are online databases. You keep it in something like Amazon, AWS, Azure, right? Cloud environment. Okay. or we call them cluster environment. Cluster. So if remember you did NoSQL in semester 2, right? Connecting to NoSQL databases from your mean stack, right? So therefore NoSQL is not completely new thing to you. But at that time we were more concentrating on web applications. But now we are taking time to look at the database aspect. Okay. Something like Mongo, we worked with MongoDB last semester 2. And there you can create, based on their cluster, you can create a database. Okay. So there you can see, try it for free. It's a cluster. There is a scalability. Okay, scalability. Scalability and availability. Right. So your NoSQL database can use different technologies to keep your data. Right. So that means NoSQL is a family of databases. NoSQL is not something like Oracle. Oracle is a data. So when I say NoSQL, it's something like relational databases. You know that there are different relational databases like Oracle, MySQL, Microsoft SQL. So likewise, there are different NoSQL databases. And different NoSQL databases you may use different approaches to save data. And sometimes the same database, NoSQL database, maybe you can configure to use this approach, that approach, depending on the type of data you work with. Okay. Right. So what are those approaches? One is document databases. This is the most widely used. You keep your data as mainly JSON documents. JSON documents. You know, JSON stands for JavaScript Object Notation. First introduced for JavaScript, and then they found that this is cool. So then almost everyone starts supporting this, even database vendors like MongoDB. Okay. Another possibility is key value databases. Another NoSQL database type. You save data as key and value pair. Set of keys and values, key value. And that value can be having another set of keys and values. Okay. The third approach is column family databases. Okay, column family databases. Another one is graph databases. So when your data is not hierarchical, like for example, Facebook, our friend network is a graph. Okay. If you take Google Map, it's a graph. Different one location connected to another location. From there, you can come to the same location, maybe hundreds and ways. So that kind of situation, we can go for graph databases. Now, what are the possibilities? Document databases, key value pair databases, column family databases, okay, and graph databases. Don't worry, we will revisit those things, okay? So as I told you, now you can see we have a lot of flexibility in our structure of data because we can pick and choose these approaches as well. And also a lot of emphasis on scalability. Scalability means when your more and more people access it, still it must be high performing. Whether 1,000 users or 10,000 users or 100,000 users, and high availability. So that means your servers are distributed. Your server is not in one place, maybe multiple places. Especially when you are developing global applications like Google, Facebook. Okay, high availability. Right. So there's a technical term here called polyglot persistence. So remember, in the modern applications, we are working with different type of data. Bit of highly structured data, semi-structured data, semi-structured also different type of semi-structured, sometimes very little structure. So therefore, sometimes we can't survive with one database. Okay. So the idea is different kinds of data could best be dealt with different data storage methods. So some data maybe we go for column family, some data key value, some data may be better to keep it as a graph. Some data maybe we should keep it as a column family and so on, or document. So then we call it polyglot persistence. Use many data storage technologies to suit your data requirements, not just stick with one. Because we need that flexibility in modern applications. Okay. So some data is using key value, some data is using relational database, some data is using relational or document stores, some data part graph stores and so on. It depends on your design requirements and so on. Okay, so these are very famous questions. Maybe they can give you a scenario and ask which database type is better. Is it relational database, XML-based database, key value pair database, is it a graph database or column family database, and so on. Okay. Therefore, these tables, these are very important for you to study. Okay, later. Right. So, what are the common characteristic of NoSQL database? From when I say NoSQL database, is a family of databases. Okay, supporting different ways of saving data. So therefore, don't think that NoSQL database is always MongoDB. MongoDB is just one NoSQL database. It is most used of obviously the JSON, but different databases can use different approaches. Right. So why do we call it NoSQL database? Because we don't use SQL. Because we can't use also because SQL is for structured. SQL word itself says structured query language. Very structured data. Insert, update, delete, retrieve. So NoSQL data, we are not expect NoSQL databases, they don't support SQL language. Okay. And most of the NoSQL databases are open source. And most of the NoSQL databases, they can run on clusters, highly available, highly scalable. Okay. And also NoSQL databases support ACID properties. Remember we discussed ACID transaction handling, we have already done. But we did not do, we did the transaction handling for relational databases. I just kept transaction handling for NoSQL databases. I told you that we'll do the NoSQL database and we'll revisit. So therefore, we have not finished the transaction handling, but we have finished the 2/3. But so after doing NoSQL database, only we can revisit and finish that topic. Okay. Right. So NoSQL databases support different data structures like graph, column family, key value. Therefore, it's very flexible. Okay. Right. So we'll stop at this point because it's 9:40 now. So in the next class, we will look at those different sub technologies like when to use column family, how do you use what are the approaches, what is the idea behind key value, what is the idea behind JSON type, okay, graph type, and so on. Okay, so that is what we are going to do in the next class. Okay. So then we are done. Okay, so NoSQL is the last one. Then there's another small sub topic related to again object oriented. Again about related object oriented. Then we are done. Okay, so we can do it, finish it in another 2 hour session.